Hey guys, I'm trying to do my best here to help you guys along with this. The first thing is there's a mastering physics assignment, just as a reminder that's due. So when you go to the Blackboard page, you can hopefully find what you need to here. Right about here. Okay, so there's a mastering physics assignment. It's called Work and Energy 1. I've also posted Mastering Physics Work and Energy 2. Today was supposed to be our double lab period, so we do kind of have to move along. And we can't really take too many breaks. So technically, we had a double period today, so we had the assignment that I had posted over Thanksgiving. So you can access that and be able to work on that today. Have that done by tomorrow. And then I also posted a mini lab to kind of jump us into elastic potential energy and the idea of conservation of energy. So this short video should hopefully show you how to get everything, but also how to do a conservation of energy problem if you wanted to tomorrow get a head start or get to work on Work and Energy 2 in case we are off tomorrow as well. Now you'll have everything you need. So below you'll see that the mini lab, it basically explains everything as far as these are your numbers of your spring constant, and so I'll show you what I mean in a second. But ultimately the document is posted on the bottom in a PDF. Click it. You should be able to click this link and it should get you there just fine. This is the document you have to turn in, and you'll notice that there's of course a graph that gets included with this. So this is supposed to try to introduce you to the spring constant and get you to have a feel for what that means. Pay attention to this, that it's actually the force that we're looking for, not the mass. And there's a bit of directions here on how to do this. But I'm going to kind of walk you through it right now, just with one trial. You want to do at least 10 different forces. All right, so when you open up PhET, you are going to want to pick on the right side here, the lab. Once this opens up, there are certain things that you need to be concerned with and others that you don't. So you can leave the energy graph there if you would like. It will help you kind of visualize what's going on here. And it explains the total energy, the thermal energy, meaning friction, or like when the spring bounces, the little metal atoms actually have friction between them. So that adds up heat. Elastic potential energy, which is what we're evaluating, gravitational potential, and then kinetic energy. So they're all there for you to look at, and it's going to create like a bar graph as this thing changes. On the right side, you want to ultimately pay attention to the top setting, which right now it's hidden by my recording feature, like the little tab. But it's the green arrow, it's the displacement one. But by clicking that, it should add this blue dotted line, and that is going to create like a reference line as to where to start. The spring constant, whatever your spring constant was assigned, I labeled it based on small being 1 and large being 10, and then there are a bunch of clicks in between, so between 1 and 10. That's how you get your number. So we're going to start it off with a small, and you're going to be on this same setting the entire time. On the top left here, you can change the mass. It's not going to let you go any bigger than 300 grams or 0.3 kilograms, so just pay attention to that, and it won't let you go any slower than 50. Ultimately, it's pretty simple. You just click, drag, and let it go. We don't want it to bounce. Eventually, this thing comes to rest. It shouldn't if there was a perfect ideal world, but there's something called damping, which is like kind of like spring friction. It saps away the energy over time, but you can slide this to 0, and or you can just leave it. It really doesn't matter to me. It's not going to change things a whole lot. But you'll notice that the blue dotted line is the reference line as to where this thing started. So when I take that off, that's the beginning. When I let this go and it damps and eventually comes to rest, or if you want, you can stop it by just clicking the stop button and it'll go to the rest position. This is known as the equilibrium position on springs. This little green arrow is actually what you care about measuring. So there's a ruler down here in the bottom right. You want to be able to grab that, slide it over, and be able to measure the different displacements that this spring has stretched, right? So the spring had a length before. It's not like it has 0 length. We could measure it if we wanted to, but we really don't care. What we care about is how much the length changed. And so we can directly measure that. Notice that this is a centimeter ruler. we need to be in meters, so make sure you convert properly. Notice also that this is in grams. We need to convert to kilograms, but what we actually care about is the force that the spring is applying to your mass. Okay, so right now it's in equilibrium, so gravity is pulling down as much as the spring is pulling up. This is an absolute value. When we record these, we don't actually care about the direction because we want the spring constant to be a positive number. Ultimately, that's it. There's really nothing else to this. You're going to change to 10 different amounts of mass, and things go crazy over here as a result, but you want to stop it at the rest position for each one of those and be able to measure things. All right, so it looks like the lightest mass, oh, that may be an issue. Oh no, this is the heaviest mass, good. So whoever has the first spring constant is going to, this is the furthest it will stretch, so it doesn't go any further than this. But you're still able to measure it, so that's the good thing. All right. If you have any questions, send me an email. I don't think you should, but this is a pretty straightforward lab. So yeah, let me know.